These are your logarithmic function notes. Yesterday we discussed that in this chapter we're going to ask you to solve various equations, and throughout the chapter we'll teach you different methods to solve these equations. So yesterday we started with exponential equations, and the method that we used was making both bases be the same number, and then once those bases match, you can take the exponents and set them equal to each other. So that method doesn't always work because sometimes you just can't make the bases be the same. So we have to then study something called a logarithm. A logarithm is the inverse of an exponential function. Last chapter we studied a lot about inverses. We learned that to find an inverse, you interchange x and y, and then you solve for y. So basically, we're going to give you an exponential form. This is read as x equals b to the y power. It could also be read as x equals b to the power of y. And the notation in between is saying this is equivalent to something in logarithmic form, read as y equals log base c of x. And so these two are equivalent to each other, but they're in different forms. Exponential having the exponent, logarithmic having the word log. And to switch back and forth between the two, what you do is if I start with exponential and I want to switch it to logarithmic, I'm going to write down the word log. I'm going to start with the base, and you write it as a little subscript over here on the side. You circle around to the other side and you write x next. Then you come back around and you set it equal to the exponent on the other side. And the reverse of that, if I give you a logarithmic equation and want you to change it to exponential form, just like we did before where we said you start with the base, we're going to start with the subscript, which is the base. You'll write it down. You'll circle over to the other side. That's your exponent. And you'll come back around and set it equal to that value. One little note before we move on, if it is not written, the logarithm or the base on a logarithm is assumed to be base 10. We count in base 10. You have 10 fingers, 10 toes that you count on. The numbers 0 through 9, there's 10 of them. Then you go 10 through 19, those are your teens. Then you have your 20s, your 30s, your 40s, so we count in base 10. So the base is important because if you don't write it, it's assumed to be the number 10. So the first thing we need to do is practice switching back and forth between the two forms. So this is read as log base 2 of 8 is equal to 3. We said we're going to start with the base of 2. Write it down. Circle around to the other side. Three is the exponent. Circle back around. Set it equal to 8. And if you do this correctly and it has numbers, it should be a true statement. 2 to the third power is actually 8. So let's try that again. Log base 4 of 16 is equal to 2. I start with the base, which is 4. I circle around to the other side. That's your exponent. I come back around, I set it equal to 16. 4 squared is 16. If I give you something in logarithmic form, I'm sorry, this is still logarithmic form. Let's do another one. Start with the base of 3. Circle around to the other side, that's your exponent. Come back around, set it equal to 729. You didn't memorize this one, but 3 to the 6th power is 729. So now would be a good time to pause the video, try number 4 on your own, write an explanation over on the right, then unpause it and see if it matches my answer. Start with the base. The base is 4. Circle to the other side. -4 is the exponent. Circle back around. Set it equal to 1 over 256. And just to give you one more vocabulary word, this number right here is called the argument, if you'd like to use that in your explanation. Okay, so let's try some that are in exponential form. This first one is 5 to the 3rd power equals 3,375. So we are going to start by writing log, because if it's in logarithmic form, it has to have the word log. The base is 15. That's your subscript. Circle around. 3,375 is the argument. And when you write that, it's on the same line as log. They should be the same size and on the same line. Circle back around. And set it equal to, I covered it up, is it a 3? 3. So this is read as log base 15 of 3,375 is equal to 3. So for our next one, write down the word log. The base is 4. That's your subscript. Go around to the other side, write 64 next as the argument. Circle back around, set it equal to 3. So one more time, pause the video, try the last one on your own, then unpause it and see if your answer is correct. Start by writing log. The base is 4. It's your subscript. Circle around. Two is the argument. circle back around, and set it equal to 1/2. And I do notice a typo in these directions. This says write each equation in exponential form. It's already in exponential form. That should say logarithmic form. So let's check this one. This one's correct. Write it in exponential form. So the reason that we learn how to switch back and forth between these two forms is because we're going to ask you to both evaluate and solve. So if you flip over to the back, the first thing we're going to do is ask you to evaluate. We're going to say evaluate what is log base 2 of 32. That means if I were to ask you what's 2 times 3, you would tell me 6. So the value of log base 2 of 32. The problem is that in order to switch this to exponential form, we have to set it equal to a variable, and I'm going to pick x. This is one of the hardest parts for students on a test because I can't tell you to do this part. You just have to know that you're going to set it equal to x. Then you're going to switch it to exponential form. So this one is 2 to the power of x is equal to 32. And like yesterday, we can take 32, change it into 2 to the 5th power, because if the bases match, then the exponents have to match. One hint is that you cannot take the log of 0 or a negative number. So when we get down to the solving at the bottom, we do have to check for extraneous solutions. Let's try number 8. In order to evaluate, you have to set it equal to something. I like x. I'm going to switch it to exponential form. The base is 3. Circle around, raise it to the x power. Circle back around, set it equal to 9. If you know 3 to what power is 9, you can jump right to the final answer. But if you're comfortable with doing what we did yesterday, change 9 into 3 squared. The bases match, so x is 2. We're not solving, we don't need brackets. Next one. Set it equal to x. Switch it to exponential form. Base is 7. Raised to the x power is equal to 343. Again, if you know 7 to what power is 343, you can jump right to the answer. Or change 343 into 7 to the 3rd power, and the bases match, so the exponents have to match as well. The only way to make it a little bit harder is to throw in some fractions and also some negative values. Same method though. Set it equal to x. Switch it to exponential form. 7 to the x equals 1 over 49. Again, this one's a little bit harder because you have a fraction on the other side, which means I'm working with a negative exponent. 49 is equivalent to 7 squared, so I'm going to start with that. But if I want 7 squared, which is 49, to go down to the denominator, I'm going to make it a negative 2. The bases match, so the exponents match as well. Number 12, set it equal to x. Switch it to exponential form. 5 to the power of x is equal to 1 over 125. Change 1 over 125 into 5 to the 3rd power, that's 125. To get it to go down to the bottom, you make it negative. Since the bases match, the exponents also match. Last two, set them equal to x. Change it to exponential form. 32 to the power of x is equal to 2. This time I'm going to change 32. It's the bigger number. So I'm going to change that into 2 to the 5th power. Multiply your exponents together. The invisible exponent over on the right side is a 1. So if I set 5x equal to 1 and I solve, I get 1/5. Set log base 16 of 4 equal to x. Switch it to exponential form. 16 to the x equals 4. Change the bigger number, which is 16, into 4 squared. You could also use 2 to the 4th power, but if you do that, you will have to change 4 into 2 squared. Multiply your exponents together. The invisible exponent over on the other side is 1. Since the bases match, set the exponents equal to each other and solve. Last part. Solving is pretty much the same thing, but we've given you an equation this time. We are trying to figure out what the variable is, and so you will use solution sets on your final answer. On the front side of this paper, we said if it's not written, the base is assumed to be 10. So on number 17, you need to write a little 10. Log of v equals -2. Switch it to exponential form, so start with the base, 10. Circle to the other side, so raise it to the -2nd power. And back around, set it equal to v. This one you just now have to evaluate. 10 squared is 100. The negative will drop it down to the denominator. Log base 4 of x is equal to 0. Switch it to exponential form. 4 to the 0 power equals x. Last chapter we talked about how anything to the 0 power is always 1. The rest of them are all the same procedure, but we're going to put the variable in different places and we're going to throw in some fractions too. So number 20, if I switch log base 36 of 1/6 equal to x to exponential form, I have 36 to the x power equals 1/6. I'm going to change 36 into 6 squared and 1/6 into 6 to the -1st power. The bases match. Set the exponents equal to each other and solve for x. Log base 5 of 1/25 is equal to x. So switch it to exponential form. 5 to the x power equals 1/25. Change 1/25. 25 is 5 squared, and to get it to go down to the denominator, it's a -2. Bases match, so do the exponents. Log base 125 of a is equal to 4/3. Switch it to exponential form. We can evaluate the left side here, but this is based off of what we learned last chapter. The 3 in the denominator of the exponent is the root, or the index, so the third root, of 125. The numerator is your exponent. The third root of 125 is 5. 5 to the 4th power is 625. Log base 128 of a equals 5/7. Switch it to exponential form. 128 to the 5/7 power is equal to a, and we can evaluate the left side. The 7th root of 128 to the 5th power, that's from last chapter. The 7th root of 128 is 2. 2 to the 5th power is 32. Last section. Log base x of 16 is equal to 4/3. Change it to exponential form. X to the 4/3 power is equal to 16. Now this one's different from the one up above. The base up above was a number, so we could evaluate. This base is a variable. I can't evaluate it. I have to get rid of the 4/3 power instead to get x by itself. So last chapter we learned how to raise both sides to the reciprocal power. So you're going to raise both sides to the 3/4 power in this case. When you multiply reciprocals, you get 1. Now I have a number that's a base, so I can switch it into the 4th root of 16 to the 3rd power. The 4th root of 16 is 2. 2 to the 3rd power is 8. Last one. Log base x of 256 is equal to 4/3. In exponential form, x to the 4/3 power is 256. Again, this one's different than the one up above because up above the base was a number, so we could evaluate, but this base is a variable, so we need to move 4/3 to the other side. So you raise it to the reciprocal power, which is 3/4. Now that the base is a number, we can take the 4th root of 256 and cube it. The 4th root of 256 is 4. 4 to the 3rd power is 64. So 2 things to note before we're done. 1, logarithmic functions are extremely useful to us in this chapter. If you get stuck and you don't know how to solve a problem in this chapter, you probably want to switch it to the other form. The other thing too, just as a hint, when you write out the word log, I tend to use a cursive L because every once in a while I have a student that thinks this is 10G instead of the word log when they read their own handwriting. So be careful of that. Make sure you know that it's not 10G and you're not solving for the letter G. That's it.